So here's our integrated one, the Chapter 5 Intro to Arithmetic Sequences. So an arithmetic sequence is very similar to a linear equation. So I figure we'll start with that first, just a little bit of review of some old stuff. So over here on the left with a linear equation, we know that we have used, and again, it's not the only form of a linear equation, is y equals mx plus b, where, defining a couple of things, m represented our slope, and b represented the starting value, which helped us with finding the y-intercept. So remember, this allowed us to say that the y-intercept was 0, b. One of the important things to note, too, I haven't really talked about it too much, is that whenever we were graphing a linear equation, I'm going to just do a quick little example here. Whenever we were graphing it, we would have some starting value and then some slope to accompany it. So we went through and we plotted these points. Additionally, we used a straight line to actually be able to connect the dots, and we extended through as well. So one of the things we didn't really talk about with this is the fact that this graph is continuous. And by continuous, I mean we do get to connect the dots. So this is continuous. So this is us connecting the dots. All right, let's talk about a few differences, and similarities with the arithmetic sequence. So let's go over here. Well, the arithmetic sequence looks a lot like y equals mx plus b. So I'm going to go ahead and bring that guy over. And we're going to make a couple substitutions here. Instead of y, we are going to call this t of n. So it's the replacement. We're still going to have a slope, but we're actually going to refer to it as the common difference this time. So we're going to call this d. And then since the y was replaced with t of n, so the whole idea of function notation, remember the thing inside the parentheses would be the same value that goes right next to the slope. So this is going to be an n plus c. All right, so let's define some stuff here. So d, this is called the common difference. It's still the idea of slope, though. That hasn't changed. N and t of n we'll get to in just a second. And then c, c is still the idea of a starting value, but when it comes to a sequence, we call it the zeroth term. Okay, so n is the replacement for x. If we're talking about a sequence, n represents a location in the sequence. So this is a location in the sequence. And t of n represents an actual value in the sequence. So this is a number within the sequence. I think this will be a little bit easier once we take a look at an example. Okay, another difference is the graph. So if we were to take a look at the graph, we would go through and we would find the zeroth term. The zeroth term is also located on what would be the y-axis. So let's say that that's our zeroth term. So that's our C location. The common difference is just like slope. So it still represents like the rise and the run business. And we would still have these dots. But a big difference is that we're not going to connect them. we would say that this graph is discrete. Discrete meaning don't connect the dots. Okay, well, let's actually do some of these problems. Again, a lot like a linear equation, just a couple different letters being changed. Okay, so we have an arithmetic sequence. Okay, so given that it's arithmetic, all right, let's write a quick little note here. An arithmetic sequence is a sequence, so it's a list of numbers. So this is a list of numbers that grow or shrink to one or the other by adding or subtracting the same number. So that is what an arithmetic sequence is. It's a list of numbers that grow or shrink by adding or subtracting the same number. So it's a lot like a linear equation. It has slope or some common difference. We want to state the common difference. Okay, let's do that first. So let's do a little bit of color coding here. So you want to state the common difference. Okay, to find the common difference, we're going to take a look at the sequence itself, and we're going to figure out how it's growing or shrinking. Now, if it's arithmetic, it's got to be addition or subtraction, one or the other. It's not going to be multiplication or division or any other weird business. And it's got to be the same number that you keep adding or subtracting repeatedly. So if I take a look at this, the first two numbers that I see are a 1 and a 15. Okay, this is getting bigger. I would have to add 14 to go from 1 to 15. Let's make sure that this works all the way through. If I take 15 plus 14, I do get 29. If I take 29 plus 14, I do get 43. Okay, that's my common difference. So common difference is the number that I just keep adding repeatedly. And remember, it is identified as D for difference. And we're going to say it's plus 14. Okay. All right, back to the question. We want to find the zeroth term. Okay. The zeroth term is not a number that we see in the sequence right now. It's the idea of if we wanted to go backwards in the sequence. So what number would be right there in front of the 1? Still using that plus 14. Well, if you're doing plus 14 to go forward, we know that we would be doing minus 14 to go backwards. So I guess what number plus 14 would give us 1? Well, that number is going to be negative 13. Negative 13, that's the zeroth term. So what is the value in front of the first one? And the zeroth term is identified as C. So in this case, the zeroth term would be negative 13. Okay, the explicit equation. Okay, that's what we wrote on the previous page, that T of n business. Okay, so the explicit equation is going to be, and we've got all the things we need right now. So our explicit equation is T of n is equal to dn plus c. Okay, let's do our color coding here. The common difference, the number that we found, we're going to plug in for d. We're going to take the c value and plug that in. We're going to leave the t of n and the n in their locations. Now we're just going to slide our stuff in here. So the common difference that we got was positive 14, and the 0th term that we got was negative 13. Okay, there's my explicit equation. Then we need to find the 17th term. All right, so here we go. The 17th term. All right, so a term, so this is a location. This is a location in the sequence. Well, the things that are identified as the locations in the sequence, those are n. So to find the 17th term, we're going to plug in n equals 17. So I'll take my t of n equation, and everywhere I see an n, I'm going to pull it out, and I'm going to plug a 17 into that location. Now, we did function notation earlier in the year. This business on the left-hand side, that's just notation. So don't do anything with that 17. But we do need to figure out what's on the right-hand side. So grab your calculator and let's type this in. So after typing this in, I got 225. So here's what this says. So let's take a look at that. This notation. This is saying at the 17th spot in the sequence, we will see 225. So if I were to continue this sequence, so I would do comma, so back up to my original sequence, add another 14, comma, add another 14, comma, add another 14. Once I got to the 17th location, the number that I would actually see in the sequence is 225. Now we've got a couple of these that we're going to do. So let's work our way through one more, and then let's see if you can do the other ones after that. So same idea. So let's take a look at our color coding here. Not that it has to be the same. All right, first thing we want to look for is the common difference. So how is this thing either growing or shrinking? All right, so let's take a look at this. Looks like that's going to be a +3. That's a +3. Okay, good. Looks like our common difference is going to be +3. And remember that the common difference is identified as D. Okay, we now need to find the 0th term. So see, I'm going to get rid of that B in front there. So what would the number be immediately in front of the 10? So what +3 gives me 10? Well, I think that's going to give us 7. So the 0th term, which is C, is going to be 7. All right, let's see if we can write the equation now. So this is our explicit equation. Which is going to be T of n is equal to dn plus C. Plug everything in where it goes. Okay, so the common difference we got was +3. And the 0th term we got was +7. Okay, now we want to find that. We're still going to stick with the 17th term. Okay, to find the 17th term, we're going to take our T of n equation, and everywhere we see an n, we're going to take it out, and we're going to plug in a 17. And then, remember the left-hand side is just notation, so we're going to leave that alone. And then we're going to type in the left-hand side. And it looks like we get 58. So if we were to continue this sequence on until the 17th location, the number we would see in that location is the number 58. Okay. Why don't you see if you can do this one? This one is a little bit different, not a huge amount. Looks like it's shrinking this time, so be careful with your common difference. So I'm going to pause the video. I recommend that you pause the video and then see if you can get the common difference, the zeroth term, the explicit equation, and then remember looking for the 17th term. Okay, so double check your work against mine. So I went through, I found the common difference. Well, because it is shrinking, it looks like the common difference is going to be a subtraction, and it is going to be subtracting 8 the entire time. So be careful that you wrote down the negative sign in front of the 8. The zeroth term, okay, what number minus 8 gives me 27? Well, that's going to be 35. My explicit equation, I wrote down my T of n is equal to dn plus c. I plugged in the common difference where it went, and I plugged in my zeroth term. And then my 17th term I went through, and I plugged in 17 for all of my n's. Now, just to be clear, it doesn't always have to be the 17th term. That's just a number that I chose. It could be the 8th term. It could be the 29th term. It is a term location, though. So really important to note here. Kind of off to the side. Very important. N, since it is a location, in a sequence, cannot, very important, cannot be a fraction or decimal or negative. It just doesn't make sense to be in a list of things and to be at a negative location or a fraction location or a decimal location. You can be in the first spot or the second spot. You can't be at the 1.5 spot. Doesn't make any sense.